So let's have a second part for our recent topic about second order non-homogeneous differential equation, part 2, a given polynomial function. So basically, we have only one problem left to solve, which is more convenient than answering two problems. Because in this video, we are not only going to identify the general solution, but we are also going to identify each particular solution because we have our given variables. Okay, so we have x as 0, y is equal to 0, and dy all over dx as 1. So we have two objectives: find the general solution and particular solution. So let's go. So here we have 7d squared y all over dx squared plus 14 dy all over dx plus 7y is equal to 35x plus 42. If you're going to observe, before we proceed to the solution, by the way, you see these terms are all divisible by 7. Take a look. On this first term, second term, third term, and then on the right side, we have 35x and 42. These terms, all of them, are all divisible by 7. So, if they're all divisible by 7, we can just simply divide both sides by 7. So we will have d squared, wait, hold on. So we will have d squared y all over dx squared plus 2 dy all over dx plus 7y is equal to 5x plus 6. So this is your simplified equation. Now what we're going to do is we can now start solving. So remember that if your second order differential equation is non-homogeneous, therefore your general solution would be y is equal to u plus your v. So you have two functions, your u and your v. So we're going to find them both. First, let's start with your u function. By finding your u function, is the same as the way how you find the general solution for your second order homogeneous differential equation. Okay, so it's the same procedure. The way how you solve the the general solution for a given second order homogeneous differential equation is the same as the way how you're going to find your u function. Okay, so by doing so, we will start by substituting d all over dx as your d. So we will have d squared y plus 2 dy. Whoa, wait. I'm actually mistaken. This is supposed to be y. Forgive me. Once again, this is supposed to be y. All right, forgive me. I forgot to divide 7y here by 7. Okay, let's go back. So plus y is equal to 5x plus 6. There you go. Okay. So now we're going to factor out your y in this expression. So we will have quantity d squared plus 2d plus 1 times y is equal to 5x plus 6. Okay, so remember, this is what you call your d operator form. Once again, this is your d operator form. Okay? D operator, as in operation. Okay? So forgive my handwriting because I was actually in a hurry to write it. So once again, this is the operator form. So after that, you're going to substitute your d as your m and equate this one to 0. So if you're going to do that, we will have m squared plus m squared plus 2m plus 1 is equal to 0. So that's it. And this type of equation is what you call as your auxiliary, there we go. Auxiliary equation. Okay? So, now that we have your auxiliary equation, we can now find your m values. Okay? So, by finding your m values, you can either use methods of factoring or quadratic formula because this is in quadratic equation. So you can either use any methods of factoring or just simply use quadratic formula. Good in factoring. Okay, you're not that good in factoring. And at the same time, you are also having a hard time to find your m values. Therefore, all you need to do is just use quadratic formula. But if you're going to use quadratic formula, let me give you some tips. Okay. This is just basically from our first video about second order differential equation, which is second order homogeneous differential equation. So remember, if we have b squared and 4ac, then we will have some conditions. If your b squared, the value of your b squared is greater than the value of your 4ac, then what we will have here for your u function is ae raised to small ax plus be raised to small bx, where your small a and your small b are your m values. So meaning, you will find your small a and your small b by finding your m values. So these two are real but different to each other. Now, what if your value of your b squared is the same as the value of your 4ac? Okay, so you're going to use 1pt ax plus b times e raised to small ax. Meaning, if you have encountered this one, meaning you have two the same m values. All right. So when I say two the same m values, they are the same to each other. So for example, I have two the same m values. Let's just say I have m is equal to -1, and I have another m which is also equal to -1. Therefore, my small a will be -1. Okay? And if you're going to use your quadratic formula, you will have only one m value. Okay? So you're going to use this one. Okay? Later, I'm going to explain more about this. And lastly, what if your b squared or the value of your b squared is less than the value of your 4ac? Therefore, you're going to use this use this as your u function, which is a times cosine of small bx plus b times sine of small bx times e raised to small ax, where your m is equal to a plus or minus b times your imaginary number. Okay, so meaning this is what? Having two m values that are complex or basically not real numbers. So if you're going to have not real numbers, therefore you're going to have this as your format. So what would be your constant term here? Your a, that would be your small a here. And what would be your partner of your imaginary number, which is your small b, will be the input of your trigonometric functions. Okay? So let's now try to use let's try now. Sorry. Let's find now your m values. So we have m squared plus 2m plus 1. So you see, if you're going to use methods of factoring, the factored form of m squared plus 2m plus 1 is m plus 1 times m plus 1. Okay? So as you can see, we have the same m plus 1s, or we have two the same binomials. So if you're going to combine them, we will have the square of m plus 1. So meaning we have two the same m values. Okay? So by finding your m, we will square root both sides. Okay, so we will have m plus 1 is equal to 0. Therefore, transpose 1 on the right, we will have m is equal to negative 1. Okay, and since we have the same m values, therefore you're going to use your u function as your quantity ax plus b times e raised to small a x. Okay, since we have the same binomials. So if we have the same binomials, then they have the same m values, which is negative 1. So since your m is equal to negative 1, therefore you're going to substitute it to your small a, in which as a result we will have 1dt ax plus b times e raised to negative 1 times x, or just simply as negative x. So this is your u function. Now let's try quadratic formula. Okay, let's try that. Okay. So that I can benefit to those viewers who would love to use quadratic formula. Remember that your quadratic formula is negative b plus or minus b squared minus 4ac. Okay? So all over 2a. So remember that this is your a, this is your b, this is your c. Now, let's see your b squared and your 4ac. So according here, your b is your 2. So we will have 2 squared. Then here, 4 times your 1 is your a. Then your c is also your 1. So we have 4 times 1 times 1. So 2 squared is 4. And 4 times 1 is equal to 4. And as you can see, they are both the same. And since they are both the same, then we will use this as your u function. So therefore, your u function is 1pt ax plus b times e raised to small ax. Now, let's find your small ax. Okay? So now let's substitute it in here to find your m values. Okay? Okay, so let's substitute. So we have negative 2 plus or minus 2 squared, which is your 4, minus negative 4 times 1, 4 times 1, it's still negative 4. All over 2 times your a, which is your 1, it's still 2, because 2 times 1 is 2. So let's simplify. We will have negative 2 plus or minus square root of 0 all over 2. And remember, since we have 0, so the square root of 0 is just 0. So we will have negative 2 plus or minus 0. And since we have 0, we can just have what? We can just have negative 2 all over 0. Because if you're going to, negative 2 all over 0. Because if you're going to add your negative 2 or subtract your negative 2 by 0, the answer is still the same, negative 2. So if you're going to divide this one, you will have m as your negative 1. Therefore, you're going to substitute it in here. So you will have u is equal to quantity ax plus b times e raised to negative x. So you guys get the technique here. So I'm just showing you two methods, okay? Not unlike in the recent video, what will be my method I'm going to use? I'm just going to directly proceed on what I'm going to do. However, for the sake of those viewers who wanted to see me using quadratic formula, then that is for you. This is for you guys. Okay? So that's it. But unfortunately, I'm going to erase this one because we are still going to find your b function. So just simply screenshot this if you like, or just simply skip this one. Go backwards like at least 5 seconds and you will see this one. Okay? So I'm going to erase this one. Now that you have found your u function, now let's find your b function. So going to your sorry, let me fix what I'm trying to say. Going to your sorry, going to your v function, you're going to base your function in it. Okay, on the right side. So on the right side, we have a function of 5x plus 6. And since this is a polynomial function, therefore your v is equal to ax plus b. Basically, I just copy the format but change the numbers into letters. So from 5x will become ax, and from 6 will become b. That's it. So now what we're going to do is we're going to substitute your v in your d operator form. So by doing so, we will have this one in here. There we go. Okay. We're going to substitute your v to your y. So we will have quantity d squared, wait, quantity d squared plus 2d plus 1 times v is equal to 5x plus 6. And once again, since your v is equal to ax plus b, so therefore we will have the same expression, but we will make v as, wait, we will make your v as ax plus b. There you go. And then let's distribute your ax plus b to this expression. So we will have d squared of, wait, d squared of ax plus b plus 2 times d of ax plus b plus 1 times ax plus b is just simply as ax plus b. No changes at all. All right, then let's just copy the other terms. Wait for it, plus 6. Now, we're going to simply resubstitute your d as your d all over dx. Okay, so if we have d squared, so meaning we will have d squared all over dx squared. So meaning this is the second derivative. So this would be the second derivative of ax plus b plus 2 times the derivative of your ax plus b. And for this one, we're just going to simply copy ax plus b because in here, since it has no coefficients other than 1, so we will have just ax plus b as a result. So there we go, 5x plus 6. Now what we're going to do is we're going to simplify. So as you can see, this is what? The second derivative. Oh? So we will have the second derivative of ax plus b. So the second derivative of ax plus b is 0 plus 2 times the first derivative of your ax plus b is just your a. Then copy the rest of the terms. So let's continue on simplifying. So we will have 2a, wait, 2a plus ax plus b is equal to 5x plus 6. So now, this is already simplified. What are we going to do now is to find your a and your b. So to find your a and your b, what we can do here is a method that we're going to simply equate the similar terms on the left side and on the right side of the equation. So let's start first with your ax, this term, your term ax. So since this is the only term that has a variable of x, now do you think on the right side there's also a similar term for your ax? The answer is yes. We have your 5x. So we will have ax is equal to 5x. Okay? And since we have x on both sides, we can cancel them out. So we will have a is equal to 5. And that would be your first equation. Next, on your left side, we have constant terms, which are 2a and b. So since these two terms are constant terms, do you think there is a constant term on the right side? Yes, which is your 6. Okay, and since we have 2a, b as your constant terms on the left and 6 as your constant term on the right, all of them are similar terms because the three of them are constants. So we will have 2a plus b is equal to 6. So this would be your second equation. Now let's find your a and your b. Actually, your a is already identified. Your a is your 5. So if your a is equal to 5, we can substitute it to your second equation. So we will have 2 times 5 plus b is equal to 6. So we will have 10 plus b is equal to 6. So transpose 10 to the right, we will have b is equal to 6 minus 10. And subtracting them will have the result of negative 4 as your b. So since we have your a as your 5 and negative 4 as your b, therefore we will substitute it to your b function. And remember that your b function is ax plus b. Therefore, we will have b is equal to ax plus b. And by further substituting the given letters here, we will have b is equal to your a as your 5 and your b as your 4. So that is your, that is your b function. So what would be your general solution? So the general solution, okay, is y is equal to u plus b. So by further substitution, we will have y is equal to quantity ax plus b times e, times, nope, there we go, times e raised to negative x plus your v, which is 5x minus 4. So that is your general solution. Okay? So we are now done with your first objective, getting your general solution. Now, after that, we are now asked to find its particular solution. So let me get the given variables here. So let me put it here. That's it. And now let's find our particular solution. So let's substitute. Wait, let me use any color here. Let me use this dark green. Let's substitute the terms here in this general solution. So we will have, since your y is equal to 0, so we will have 0 is equal to quantity, quantity a times 0 plus b times e raised to negative times 0 because your x is equal to 0 plus 5 times 0 minus 4. Okay, so with simplification, we will have 0 is equal to quantity. A times 0 is 0. Wait, my application is lagging. Hold on. Okay, there we go. There we go. So 0 plus your b times. So negative times 0 is still 0. So e raised to 0. And remember, anything raised to 0 is equal to 1. So we will have 1. Okay? Plus 5 times 0 is 0 and minus 4. So with simplification, I meant to say by simplifying even it further, we will have 0 plus b times 1, it's still b. Then 0 minus 4 is negative 4. So that is your b. And now, what we're going to do here is we're going to simply, what? Find your b. So since we have your b here, so we will transpose 4 to the left and we will have 4 is equal to b. So that's it. But how can we find your a? Can we substitute your 4 going in this, oh wait. Can we substitute 4 in this specific equation? The answer is no, obviously, because you will not find your a value. So, if you're going to take a look, we have dy all over dx is equal to 12, right? So that means we can have another equation by simply getting the first derivative of your general solution. Hence, we can have dy all over dx is equal to getting the product rule of the first term. We will have ax plus b times negative e raised to negative x, okay, plus plus e raised to negative x times a. There you go. All right. Plus the derivative of your 5x will just be 5, and the derivative of your negative 4 will just be 0. Now let's substitute. So dy all over dx is equal to 12. So we will have 12 is equal to a times, since your x is equal to 0, so we will have 0, 0 plus b, all right, times negative e raised to negative times 0, okay, plus e raised to negative times 0 times a plus 5. So here we will have, you see, 12 is equal to 0 plus b, and as usual, we have negative e raised to 0. And once again, anything raised to 0 is equal to 1. Okay, so we will have 1. But since we have negative sign here, so we will have negative 1. Okay, so we will have negative 1 as a result. Plus, and again, anything raised to 0 will what? Will result to 1. So we will have 1 times a plus 5. Okay, so we will have 12 is equal to 0 plus b is b times negative b is times negative 1 is negative b plus a plus 5. And remember that your b is equal to remember that your b is equal to 4. So therefore, we will have 12 is equal to negative 4 plus a plus 5. So if you're going to combine similar terms with negative 4 and your 5, we will have a plus 1 because 5 minus 4 is 1. Then transpose 1 to the left side, we will have 12 minus 1 equals a. So we will have 11 as your a. So therefore, what do you call this one? Since your b is equal to 4 and your a is equal to 11, we can now substitute it in these letters. Okay, so let me just copy this for a moment. Let me put it here. Okay, so we will have y is equal to quantity. Your a is 11, so 11 times x plus your b, which is your 4, times e raised to negative x plus 5x minus 4. All right, so this is your particular solution. So that's it. And we're done here. Let me rewrite this one first. There we go. So I hope you have learned something here. don't worry, I'm going to upload the practice tests, like the first practice about second order differential equations. So maybe we could at least have a mastery about this topic.